All right, hey guys, we are going to do the second half of lesson 10.5 that we started yesterday. We're going to keep working with compound probability. Make sure you have your math book and a calculator ready for today. All right, so today we are going to be looking at the theoretical probability of compound events. So we've already talked about theoretical probability. It's what should happen. So today we're going to look at theoretical probability of the compound events like we were doing yesterday. All right, so here would be an example. So let's say that I toss a coin and then I roll a dice. Somebody made a tree diagram that shows the sample space, remember we talked about that yesterday, of all the different outcomes I could get. So I could get a tails and a 1, a tails and a 2, a tails and a 3, 4, 5, 6, and then same thing, I get a heads and a 1, heads and a 2. Total, there are 12 different outcomes. So today I'm going to ask you, say, what's the probability of getting a tails followed by a 6? So I want to get a tails and a 6. All right, so if I am looking at my tree diagram, I only see that happening once. Tails and 6, I just highlighted in pink. So my probability is 1 out of, there's 12 possible options, so that would be my probability. Now, if we want to change that to a decimal, you can just grab a calculator and do 1 divided by 12, which I am typing in right now. That is about 0.083, so that is about 8.3% repeating. That's your chances of getting a tails followed by a 6. So if we go to page 552, here's our next example. So we're going to try to find the probability of, if I have 2 dice, I'm going to roll them. So roll each of them once. What's the probability of rolling a sum of 9? So first thing, a sum of 9 means like if I add the 2 dice, it equals 9. So I want to know all the different options that I could get of rolling a sum of 9. So if you think about this, we have a couple options. We could either draw a chart or we could draw a tree diagram. You can kind of use either one that you want. So on page 552, you're going to see that they actually made a chart for you. So they put, hey, here's roll 1, you could get a 1 through 6. Here's roll 2, you could get a 1 through 6. Now, after you would make something like this, so they did it for you, here's what I would suggest. You're going to shade or circle the cells that if I add them up, they have a sum of 9. So let's just kind of, you start going through, I'll just kind of think about this. Well, 1 plus 1 is 2. 2 plus 1 is 3. That's 4, 5, 6, 7 together. None of those make 9. So you need to kind of go through and circle the ones that when you add equal 9. So pause the video and please do that. All right, well, here's one. That equals 9 together. This equals 9 together. This equals 9 together. This also equals 9 together. You can kind of see a little pattern there. They're kind of all in a row. So there are 4 total chances of me getting a sum of 9 out of, there's 36 total possibilities. Remember, you can get that by thinking, hey, when I roll a dice, there's 6 different options. My other dice also has 6 different options. 6 times 6 is 36. Now, I can simplify that. If I divide it down by 4, I get 1 out of 9. And then if I change that to a percent, it's about 11.1%. And again, you guys do know to change it to a percent, you do 1 divided by 9 times 100 to get to a percent. So you just found the theoretical probability of rolling a sum of 9. So let's try the check on page 552. This time I'm going to toss a coin and then I'm going to roll a dice. I want the probability of tossing tails and landing on an odd number. So why don't you guys pause the video and try this, and then I'll go through it. All right, so this time I'll just draw a little tree diagram. So in this one, I'll just draw a tree diagram. So if I'm tossing a coin, I can get a heads or a tails. And then when I roll the dice, I can get a 1, a 2, 3, 4, 5, or 6. Same thing with the tails. I can get tails and then a 1, 2, 3, 4, 5, or 6. All right, so total, when I flip a coin, I have 2 options. When I roll a dice, there's 6 options. 2 times 6 is 12. There's 12 total outcomes. That goes on the bottom, possible outcomes. Now I want to get, it looks like a tails and then an odd number. So I need to highlight or circle the ones that have tails and odd. Okay, so I could get tails, it's going to be over here. Tails in 1, tails in 3, or tails in 5. So there's 3 different things I could get. So 3 out of 12 is my theoretical probability. If I simplify that, I can divide by 3. I end up with 1/4. And then to change that to a percent, 1 divided by 4, that gives you 25% chance of getting a tails and an odd number. And again, that's the theoretical probability. Now, if I actually did this, that would be the experimental, like what happened, or the relative frequency when I actually did. All right, let's look at example 4. I'm finding a probability of a compound event again. This time I am tossing 2 coins, and I am rolling a number cubed, a dice labeled 1 through 6. I want to know what's the probability of getting heads at least once and rolling an even number. So we're going to either need to make some kind of chart or a tree diagram. Now I'm going to tell you, when I am doing something like this, if there's more than 2 events, I usually always do a tree diagram. If there's only 2 things, a chart will work. So I'm going to draw a tree diagram. You could also do a list, but you do have options. All right, so you can see that they kind of drew this out. So on your first coin toss, you could either get a heads or a tails. And then if you got a heads first, then you could get a heads or a tails. And then after that, you could get, so I could get like heads, heads, and then a 1. Heads, heads, 2. You can see as I'm following it. Heads, heads, 3. Heads, heads, 4. So you could kind of get like that, or heads, tails, 1. Heads, tails, 2. Same thing here. Tails, heads, 1. Tails, heads, 2. So those are all the different things that you could get. We practiced writing these out the other day. I'm not going to do every one. But if I follow this branch in blue that I just highlighted here, that would be, I got heads, heads, and 1. Okay, I'll pick another branch to kind of highlight just so you make sure. This would be tails, heads, and 2. So that's kind of where you get that from. Now, if you're looking at the total number of outcomes, when I flip my first coin, it's 2 times. My second coin, there's 2 options. And then my dice, there's 6 options. So 2 times 2 is 4, times 6 is 24. There are 24 possible outcomes total. The next thing I want to do, I'm going to just grab pink for this, is I want to find all the ones where I get at least heads once and an even number. Okay, so I need to at least get heads once. So if I'm looking at this, I get heads once here, right? Even though it's twice here. All of these I would get heads at least once, right? Because heads, heads, or heads, tails. So I need even too. So heads, heads, even, heads, heads, even. Here's another even, 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 even. So far there's 6 over there. And then down here I need to get tails at least once, or not tails, heads at least once. And then I need evens. Looks like there's 3 more. So 6 plus 3 is 9. So my final probability is 9 out of 24. I can divide that down. So if I divide by 3, I end up with 3/8. Now if I grab my calculator and change that to a percent, because we've been doing that, 3 divided by 8 is 0.375, or 37.5%. So that's your probability of getting heads at least once and an even number. So let's have you guys try the check on page 554. So why don't you try this one and play the video after you've had a chance to try it. All right, so it says I have a spinner with 3 equal size sections with red, green, and yellow. So first thing, I could get 3 different colors, red, green, and yellow. Then I'm going to toss a coin. Well, you can get heads or tails, so 2 options. And then I'm going to pull a card, and there's either a 1 or a 2. So again, 2 options. So I already know my total. 3 times 2 is 6. 6 times 2 is 12. There's 12 different outcomes. So I know that's the bottom of my fraction. So now, since there's more than 3 events happening, I'm going to draw a tree diagram. All right, I'm going to draw an up and down one this time. So I can get red, I can get yellow, or I can get a green. Now keep them spread out so you have plenty of space. So let's say maybe I get red to start with, then I'm flipping my coin. I can get a heads or a tails. I could also get yellow and then heads or tails. I could also get green first and then heads and tails. So my spinner was first, then the coin, and then finally I'm drawing the card. So I could get red's head, and then I can either get a 1 or a 2. Here, a 1 or a 2. 1 or a 2 is my next branch of my tree diagram. A 1 or a 2, 1 or a 2. All right, so again, I can see that there are 12 options. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Now I'm going to highlight the ones that actually work in my problem. I need a yellow, so I don't even care about the red and the green, heads, and a 2. Well, here's yellow, heads, and 2. There's only one of those to get a yellow, heads, and 2. There's 1 out of 12, so that is my probability. And then if you change that to a decimal and a percent, the decimal is 0.083 repeating, which is about 8.3%. All right, if you go to page 554, I want you to read through this question and try to answer it to see if you can tell me what's the difference. So the language you use is very important. There's a difference between saying rolling a 3 or a 6 and rolling a 3 and a 6. If I said a 3 or a 6, that means I could get either of them. So like on a dice, if I just rolled it one time, there's 6 different options I could get, 3 or 6. Those are 2. There's 2 choices for there. A 3 and a 6 means I would have to roll the dice twice, and I'd have to get the number 3 and 6 for that to be the event. So those are definitely different wording. All right, we're going to try one last problem on page 554. So if you guys can go to that page. Here is our problem. So it says, John, he tosses a quarter and then he spins a spinner with 8 equal size sections labeled 1 through 8. He does this 80 times and he finds the relative frequency of getting heads and a number bigger than 6 is 3/20. So that means when he did it, he figured out his probability was 3 out of 20. That was the relative frequency, or that's what happened in the experiment. So I want to know how many times did he actually get a heads and a number bigger than 6. So again, that's what I want. A heads and a number bigger than 6. All right, so when I do that, if I want to figure out how many he actually got out of 80, I'm going to say, okay, he figured out that the probability was 3 out of 20, but how much out of 80? Well, from 20 to 80, that's 4 times bigger. So 3 times 4 is 12. So he actually got 12 times he got a heads and then a number bigger than 6. All right, now I want to know what's the difference between the number of expected outcomes, what we thought would happen, and what actually happened. So this is what actually happened. Now let's do what we would expect to happen. So the theoretical probability. So I'm going to draw a chart for this. And let's see what happens. So first thing he tosses his quarter, he can get a heads or tails. I'm going to do a chart for this one. Then he spins the spinner. He can get a 1, a 2, a 3, 4, 5, 6, 7, or 8. Okay, so I'm just going to kind of split this up and write all my possible outcomes here that he could get. So he could get a heads and a 1, heads 2, heads 3. You guys can fill this in. This is not too hard. Okay, so I'm just filling in all the different things he could get. Heads 8. Then I do tails 1, tails 2, 3. You can keep going here. All right, and I have all my different outcomes. Well, if I look at that, it looks like there are 16 different ones. Again, makes sense because there were 2 options for flipping a coin and 8 options total, so 16. So now let's see how many times did he actually get a heads. Oops, I didn't mean to erase that. A heads and then a number bigger than 6. And we're going to highlight those in our chart. All right, so a heads and a number bigger than 6. It looks like there's just 2 of those. Heads 7 and heads 8. So that's 2 out of 16. I'm going to simplify that. Let's divide it down by 2. So we would have expected him, before he actually did it, to get a heads and a number bigger than 6 1 out of 8 times. So what if he did it out of 80? Well, if it's 1 out of every 8, let's see how many we would think out of 80. Well, it looks like it's 10 times bigger, so if I times it by 10, it's 10. So I expected him, this is what I expected, the theoretical, to get a 10 of those out of 80. He actually got 12 out of 80. How far off was he? He was 2. He did 2 better than we thought. So he was 2 off, but that's pretty close. All right, so now you are going to go ahead and try a class kick to practice finding the theoretical probability of a compound event. Hopefully you feel okay on this. Please make sure you check in with your teacher if you need help.